Hey everyone, welcome back. So far in STL we covered almost all important STL containers used in DSA, vector, DQ, stack queue, priority queue, map. Right now it's time to answer the most of the questions. Which container should I use and why? The answer lies in time and space complexity. Why complexity matters? In interviews and the competitive programming, you are not judged on correctness, you are judged on efficiency. So most of the time whenever you are giving your solution to the interviewer, they always judge based on what is the time complexity of your program. And as for the STL container, whenever you are solving a problem, you can solve a problem with a multiple STL container itself, but which container you should use while solving the problem, it depends on the time and space complexity of that container. So let's first look what was the common time complexities we have seen. First one was big of 1, which is constant. Then we had big of n, which is linear. Then we had log n, which is logarithmic. Then we had n log n, which is linearithmic. And there is n square, which is quadratic. Okay, there is other, but for STL containers we only need these time complexities. Okay, now let's start with the vector. So we know that vector is similar to the array, but it is dynamic in nature. Means in a running time you can add data and remove data. So whenever you are accessing our data in a vector, let's say if you are accessing this value using v of I, or I is our index, it takes an time complexity of big of 1. If you are adding a value using pushback, it takes time complexity of big of 1 itself. But this big of 1 is amortized, means it analyzed based on the average cost. Means if our vector size got increased or decreased, and in all these cases we are taking the average time complexity, which is we call amortized time complexities. Then to remove a data we use popback. Its time complexity is big of 1. If you want to insert a data, right, or erase a data, its time complexity will be big of n, because let's say you have an array like this, and if you are inserting a value 10 here, what will happen? These all values will be got shifted by one position, right? So it will become like 2, 3, 10, 1, 5, 4. So the index number of these values got changed. So in the worst case we have to shift all the values itself. So the number of operation it will take will be big of n itself. And if you want to search data inside the vector, it will also take big of n. Okay, so for pushback we have a big of 1 amortized. For removing the data we have big of 1. For accessing the data we have big of 1. For inserting and erasing we have big of n. For searching we have big of n time complexity. So before using a vector in your program, make sure double check the time complexities. Now let's come to the DQ. Right, this is our DQ. It is a double ended queue, right? So we can insert from here, remove from here, also insert from here and remove from here. And in DQ we cannot access from the middle, but we can insert in the middle. Okay, let's look what is the time complexity to access. So we can only access using front or back, right? So the time complexity it will take big of 1, because we have to check first or last value. For adding value from the back it will take 1. For adding value from the front it will take 1. Similarly for removing also it will take 1, right? But for inserting in the middle it will take big of n. Now let's look at the stack and queue, because both of them are similar. One is from the top and the queue is from the back. So for push, pop and top it will take big of 1, right? Similarly for this it will take 1. And for stack and queue there is no middle, right? We cannot access in the middle of the stack and the queue. Now let's look at the priority queue. So in priority queue it depends on the max heap or min heap, right? If it is a max heap, the largest value will be at the top, and if it is a min heap, the smallest value will be at the top. So whenever you are pushing a value or inserting a value, it always takes log n, right? Because let's say if you have inserted a 2 here, then 1 here, then the internal rearrangement will happen and the 2 will come at the top. So that's why it is taking log n, because there is a extra operations happening after inserting the value itself. Similarly, for removing, it will take log n, but for checking what is the value at the top, it will take 1. Okay, now let's come at map and multimap. It is similar, means in map and multimap it is sorted, right? So if it is sorted means we inserting data in any order, but internally it got rearranged, so the insert will take login. Searching also take login, means if we are using find function, it will take login, or even we are deleting, it will take login. Now let's look at the unordered map. For a unordered map, the data is unorganized, so insert will take 1, searching also take 1. But in the worst case, in unordered map we have a 2 case, average and worst. So in the average case, it will take 1. Also for delete, it will take 1, means it is inserting. If it is searching, it may find the value at the beginning itself, so we can say in the average case it can be 1. But if it have to search the whole map, it will take worst case, and similarly for this it will take n, and also for deleting it will take n. So for a unordered map, there is a chance that our operation will always be in average case, so our time complexity will always be big of n. But in rare cases where worst case can happen, so our time complexity will become n, which is worse than login, right? Login is better than n itself. So if while using unordered map, if there is a worst case scenario, the time complexity will increase. So in this case, you have to use ordered map. Multimap and unordered map is similar to the set, unordered set and multi-set, so you can say their time complexity is similar to each other. Whenever you are solving your program, always try to use unordered map and unordered set for the average time complexity. If in some cases your program giving time limit exceeded, there is a term time limit exceeded, we will see what is it, then in that case you have to use map itself. Okay, but in most cases always use unordered map for a better time complexity. If it is giving time limit exceeded, which is called TLE, you have to use ordered map itself. Okay, that's it for the time complexities of STL containers. And as we keep solving the problems, we will keep analyzing the time and space complexities, and you will get the proper hang of it. Thank you everyone.